just a minute.
Okay, sir.
So a very good morning to one and all. I welcome back all the participants to the day 4 session 1. I take this opportunity to welcome our resource person, Dr. T. Kishore Kumar Garu, a professor in Department of Electronics and Communication Engineering, NIT Warangal. So we welcome for another session on adaptive signal processing and applications. Sir, now I request Dr. T. Kishore Kumar sir to take over the session, sir. So thank you, sir.
Okay, sir. So thank you, sir, for giving the brief introduction. I think 2 days back, I started this program with machine learning and its applications. I hope that everybody attended that particular program. Now today, in fact, my topics which I want to deliver is today there are 3 parts, rather 4 parts that I'll try to deliver. The first part is I'll try to give the basic idea about signal processing and various applications where we can come across this machine learning. And the second one is adaptive filters and its applications. And then afternoon, I'll try to give an idea about speech processing. And in the fourth part, how we can implement all these the basic fundamentals with the help of Python, how we can do it. In fact, my colleague, Dr. Kishore, Suresh, I think he gave the idea about Python and its fundamentals. But today afternoon and if possible 18th afternoon, I'll try to provide the demos or the hands-on session on these particular aspects. Okay. So now I will try to share my PPT. Is it visible, my PPT?
Yes, sir.
So basically, in order to have idea about signal processing, one should have idea about a signal. Okay, so a signal is a function of one or more variables which conveys information on the nature of physical phenomena. Okay, so there are different types of signals that you are observing here. One is speech signal, which conveys the information, whatever we speak. So the voice is converted into an audio and we are hearing that particular voice. It conveys some information. Then ECG signal. So in order to know the heartbeat of a particular signal, and in order to have the various applications of this particular ECG signal, in fact, this is actually one of the major biomedical signal processing application input, where we can perform the so many inferences from this particular ECG signal. We can what we can say, know the functioning of a heart and what type of the blood pressure that we have, and how we can proceed the heart diseases, all sort of things that we can achieve from this particular ECG signal. Then there is a general sinusoidal voltage signal, where we can we will know the characteristic of a particular signal. And then radar signal, basically this radar signal which is used to actually to, if you want to detect the target position. Suppose in a space an aircraft is moving with certain speed, then if I want to know the position and range of that particular target, I can transmit a radar signal and then I can receive the received pulse, and then I can calculate the range and position of that particular target from at what particular distance it is traveling. Not only that, various the principles that we can find out with the help of this particular radar signal, especially in DRDO. Most of the research which they are performing with the help of this particular radar signal processing only. And then the other signal is the two-dimensional signal, where this particular two-dimensional signal, which is what we can say the image signal, where we can perform different types of applications. I'll try to show those things. So put together all these particular signals, either speed signal, ECG signal, radar signal, image signal, all these signals which they will communicate some information, which is a function of one or more variables, which conveys some information on the nature of physical phenomena. So this is what a signal. And basically these signals, we can classify different types of signals as we have studied in the signal processing. Basically, we have a continuous time, discrete time signal, periodic, non-periodic signal, causal, non-causal, even and odd signal. So these are the signals that we are familiar with these particular signals. But the very interesting thing is the deterministic and random signal. So these are the signals. Actually, these days people are applying the machine learning techniques or artificial intelligence techniques in order to predict the nature of a particular signals. When you take the deterministic signal, there is certainty that is present, and we can predict the nature of a particular signal. There is the suppose if you take a particular the signal at a particular instant of time, then at t plus 1 or at t plus 2, what would be the position of that particular signal I can predict. But in the case of random signal, I cannot predict the nature of particular signal. So there is uncertainty that is present in the random signal. Okay. So in order to process this particular deterministic signal, I can go with filtering concept. But whereas in the case of random signal, if you want to predict the random signal, then there is a the uncertainty that is present. That's why we can go for estimation rather than the filtering concept. So these are the two signals where we need to process a signal, means a challenging task that we can come across. Random signal is very, very important signal. So in all these particular day-to-day life, we are facing the different types of signals in a domain is the random signal. And of course, I'm not touching these things. Actually, there are two types of the analysis are there. One is time domain analysis, another one is the frequency domain analysis. In the case of a time domain analysis, of course, this is olden the method by using the strip chart recorder. So we can record a particular signal, and there is a stylus is there, and if you write a particular information, that particular information which will be plot on a particular signal, and which is amplified, and then we can take a printout of that particular signal. That is in order to have the olden days time domain analysis, people use strip chart recorder. Then afterwards, we have a oscilloscope. So with the help of the cathode ray oscilloscope, we can plot and we can study the characteristic of a particular signal. Nevertheless, what we can see that in the time domain, the signal that we are representing in terms of its impulses, and we can get an output. So the output is the convolution of the input and the impulse and its input. So, or we can say that the product of input and its impulse is called the time domain analysis. Similarly, in the case of frequency domain analysis also, we can represent the signal, frequency domain representation of the signal in terms of its impulses. So the signal processing itself, I can say that it is a Fourier series representation of a signal. So what we are representing in a Fourier series representation, in the Fourier series representation, I am representing the signal in terms of its sine and cosine terms. So similarly, in the case of signal processing, how I am representing a particular signal, I am representing the signal in terms of its impulses. So, and if you see, the over 80% of all the DSP applications require some form of frequency domain processing. Any form, waveform can be produced by adding sine waveforms together. So here, if you see the frequency domain representation, we have a input, then we have the impulse response, and then we can get a output. So both the things are same. In the time domain analysis, I am representing in terms of time domain, and in the frequency domain analysis, I am representing in terms of the spectrum, the frequency domain representation. So now what I can conclude from this thing is, I can represent a signal like in terms of Fourier series representation, signal processing also I can represent like that. So I can say that signal processing is decomposition of the signal in terms of its impulses. So everybody should remember that decomposition of the signal in terms of its impulses is nothing but the signal processing. Even in the case of the machine learning, what we are doing is we are trying to decompose a particular signal, and we are extracting the required the features, and then we can classify these particular features. So in the signal processing, whatever we are considering, the unwanted the signals which we will remove, and the necessary signals only we will try to take, and we can classify these particular signals, and we can predict the nature of a particular signal. So one must remember that in a signal processing, there are two types of the analysis are there. One is called the time domain analysis, another one is called the frequency domain analysis. In both the cases, we are trying to decompose the signal in terms of its impulses. So the decomposition is useful in the case of machine learning. So either I can extract the features, or either I can classify the features. So you must remember, as I told you, in the case of the machine learning application, any type of the signal processing, there are two things that will be there. One is called the feature extraction, another one is the feature classification. So this is the relationship, and then you can see that the system, after knowing the particular signal, then system is which is an entity that responds to a signal. So there are different types of systems, which we know that RC system, then we have a camera, then speech recognition. So for whatever the for a corresponding to a input signal, the output will respond. So there are different types of systems. Everybody familiar with these particular systems. Mass spring is one example. Tank is another example. Cell phone system is another example. Then we have, if you see the day-to-day conventional the purpose, we are observing that. So how we can transmit a particular signal. The when you make a call, how it will transmit and it receive the receiver end. Okay. So now coming to the after having that particular after knowing that particular signal system, this systems also classified into different types of systems: continuous and discrete time systems, then linear and non-linear systems, time variant and time invariant system, causal and non-causal systems, stable and unstable systems. So coming to the real world signal processing. In the case of the real world signal processing, we have two domains. We have two domains: analog domain, another one is the digital domain. Analog domain and a digital domain. Okay, so in the case of analog signal processing, we will use the analog to digital conversion. And the case of the digital signal processing, we can use digital to analog conversion. Can anybody tell me how we can convert analog to digital? Can anybody tell me how we can convert analog to digital? Because all are participants, so you please respond. Not all the people.
Using analog to digital converters.
What are the different methods that we can convert analog to digital? No, please, you have to respond. Otherwise, it is not simply sitting and you can listen. Okay.
Successive approximation technique, sir.
So that if it is an interaction session, even in the first class also I told. So if it is interaction, sampling,
Quantization and coding.
that is actually analog to digital converters. I am asking, of course, you are talking about quantization, sampling.
Successive approximation technique, sir.
Yes. Successive approximation technique, and there are dual slope approach. There are different types of approaches are there in order to convert analog to digital. Similarly, for DTA conversion, anybody?
R2 ladder.
Yeah, R2 to R ladder.
Weighted DSC.
Yes. Okay. With the help of those things, we can convert that. Okay. And then in the case of DSP processing, we can use different types of DSP techniques. So different types of techniques such as convolution, autocorrelation, I'll try to show those things. So with the help of these fundamental techniques, we can process and we can convert into digital domain. Again, for the end user, people need to use the analog output, so they will convert into digital to analog. So this is actually the real world scenario where there are two domains are there. One is the analog domain, other one is the digital domain. So various applications of the signal processing are there. So you are familiar with this, all these things. Okay, I need not tell these things actually. So everywhere nowadays we are observing that these are the different types of types of these particular things. 1 minute. So now coming to the signal processing, so what are the different operations that that we can perform the operations in the case of the signal processing? One is the spectrum analysis. As we have seen that the spectrum analysis is decomposing the signal in terms of its impulses. Okay, so decomposing the signals in terms of its impulses, in any case, either it is a spectrum or it is a signal, so we need to decompose that particular signal. So there are spectrum analysis means there are different types of analysis approaches for the analyzing the particular spectrum. Then coming to, in the case of the signal processing, we can come across the digitization, reconstruction and compression. So as we have seen that the analog thing, we need to digitize. After digitization, we need to reconstruct, and then sometimes, suppose if the bandwidth, if the memory will be more, then we need to compress. So then we need to transmit. So image, when you take the image, we need to compress, then coding, and the sound coding or the other source coding. All these things we need to do. So the first operation that we can come across in the case of signal processing is spectrum analysis. The second one is digitization and reconstruction. And third one is the storage, where in digital delays, lines and reverb. And the fourth one is the modulation. And the fifth one is the prediction. So all these particular operations, of course, there are the other operations which we can use it in the case of signal processing. These are some of the what we can say, the operations that we can use it in the case of signal processing. So this particular signal processing, it not only useful in one particular domain, in all the particular the other areas also we can use this particular signal processing. So if you see the communication systems in the networks, computer networks, so we can use this particular signal processing. So if you take the OSI layer 1, in the case of physical layer, there are 7-layer system will be there: physical layer, presentation layer, network layer, transportation layer, like that we have a 7 layers will be there. Even in that particular layers, if you take the physical layer, so in the physical layer I can use it the signal processing techniques, like I can apply the modulation, equalization, multiplexing. So these things that I can use it for the signal processing. And in the case of the layer 6, that is in the presentation layer, like source coding, including analog to digital conversion and data compression. So these things that we can use it. So what I mean to say is the signal processing techniques such as modulation, equalization, multiplexing, or the source coding, the analog to digital conversion, and the data compression. All these things that we can use it in the case of communication systems also while performing the signal processing. If you see here the OSI reference model, this is actually the 7 layers. Everybody have idea, that is we have a physical link layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. So in all these particular layers, as I told you that in the case of physical layer, we can use this particular signal processing techniques like modulation, equalization, multiplexing. And in the case of presentation layer, I can use analog to digital conversion, data compression, and source coding. So, so in the OSI reference model, also I can use the signal processing techniques. Now, why do I want to go for signal processing? So one must should have an idea in signal processing. So any particular application when you want to do, so in the case of signal processing, so these are the major the operations that we can apply in the case of signal processing. So most of the people, they're faculty here, most of the people they're pursuing research. So if you want to do research in the case of signal processing, so either just now I told you that machine learning concept, AI technique are different types of the tools that we can use it for a signal processing. So in these particular operations, one must use those particular tools. One is the signal analysis. Just we will spend some time on this. So this is very important concept that everywhere. So in signal processing, any particular tool, either it may be a MATLAB, it may be a machine learning tool, it may be a Python program, it may be a what you can say the LabVIEW. So whatever the language tool that I need to use to apply for these particular techniques. So one must should have the thorough idea about these particular operations. So if you take the signal processing, these are the important, very important some of the operations. Apart from this, there are so many operations are there, but these are the major the operations that one must should have the idea. So we will try to discuss a little bit detailed here. So first one is the signal analysis. So signal analysis means, so just now we have, I told you that by decomposing the signal in terms of its impulses, I can get some particular, the plot of a particular signal. And by looking to that particular signal, so I can see the transition, pattern, peaks, frequency distribution. Okay, so can anybody give me example of some 2 3 signals, and how we can analyze the signal analysis? Can anybody? Give me example, one or two examples, whatever you have come across, because most of the people are a faculty or the scholars. So in your applications where you are using the signal analysis. So don't worry. So don't think that the answer is wrong or somebody sees that it is an online program. You need not worry about that. You just share or you can interact. So anyone who are teaching or who are doing research on this signal analysis, give an example, signal analysis. And I have given some example. What are the things that we can observe from that? Anyone?
Sir, people are answering in chat box, sir. Please verify chat box once again, sir.
Uh-huh.
Please open chat box, sir.
Chart.
Chat box, sir.
But here I am not getting chat box. It should come now.
You may found on the top, sir.
Top only I am seeing there is a mute start video security participants and new share pass here. Actually, chat box should come actually. Remote control and more is there. That's all.
Sir, you can found on the top side, I think, sir.
Top only I am watching. I am observing top only, ma.
Sir, just see the participants, sir. In the participants option is there, sir. Chat option. Just click on participants, sir.
Yeah, I click on participants. In participants, then invite mute all is there, ma. What where we can get? I think.
Sir, otherwise I will give, sir. Here the participants given these are ECG, EEG, and EMG. These signals they are given, sir.
No, you cannot ask them one person like that where how they are using that. It is not possible. Huh? Any problem? Any problem? Huh? Okay.
Participants can directly talk. They can unmute yourself.
No, they can tell na, so that because I can discuss those things.
Dear participants, please unmute yourself and talk to the sir, Kishore sir.
Okay, so everybody, whether they are listening or not, I don't know. Okay, so just now I think somebody in chat box they are telling that it is a ECG signal, EMG signal like that. Okay, so from that we can from the transition from the pattern. So the type of a pattern as we have seen that ECG signal. So depending upon the pattern, so there is a PQREST will be there in ECG signal. So if any abnormality or if any variation that is there, I will try to show that at the other thing. So any variation that occurs, that the shape of the particular pattern varies. So once if the pattern changes, easily we can recognize that there is a abnormality that occur. The peaks, then the second one is the peaks. So normally in the case of the speech signal or some particular signals, peak indicates the voice signal. So if a peak is not there, then I can say it is a silence. So depending upon the peak, I can guess that whether the signal contains a voice or not. Then frequency distribution. See here, so normally in power line communication, there are fundamental frequency and harmonics are there. So depending upon the fundamental frequency, the number of harmonics that occur, based on that harmonics, I can classify, I can analyze the signal. So that means from the signal analysis, irrespective of type of signal, it may be a biomedical signal or it may be image signal or it may be a a type of a signal, automobile signal, or whatever the signal that we can come across from the transition, from the pattern, from the peak, from the frequency distribution, we can analyze the signal. So in the case of the analysis of a particular signal, again, we need to classify, we need to decompose that particular signal in terms of its necessary signals. So there I can analyze the signal based on the transition, based on the pattern, based on the peak, based on the frequency distribution, and based on the other particular parameters. I can, what we can say, I can analyze a particular signal. So the first operation in the signal processing is signal analysis. The second one is the signal decomposition. We have elaborately discussed previously, that is separating the messages or separating the message and noise. So normally we can, the signal processing means we can come across the noise and the signal. We need to separate that particular noise. So in that case, we can go for the signal decomposition. Then the third one is feature enhancement. Feature enhancement is the actually the very important the aspect, either in the case of speech processing, image processing, or biomedical signal processing. So what are the different types of features which we can come across in the case of what you can say, in the case of this type of signals? Can anybody tell me, or you can keep in the chat box? I think somebody will help me. What are the features? Hello? Lecture lo normally. So in the case of the feature enhancement, what are the different types of features? Can anybody tell me what are the different types of features?
Sir, if image is blurring image, we can remove that.
Okay, okay, blurring. You can say that blurring. Okay. Now here I am talking about the feature enhancement. Feature enhancement. Blurring. Okay. So you have to sharpen a particular image. This is one type of thing. Okay. So, so here you, if you observe, the feature enhancement basically useful for the boost the signal component, sharpen the images. Okay, as you told that the blurring, this particular blurring we can remove, and we can sharpen the particular image. Okay, so normally any type of signals, suppose when you take the simple example, one example these days I will tell biomedical application, some particular, what you can say, the some transducers like knee disorder people want to do. So there is a research topic is there, knee disorder. So in order to know that particular knee disorder, what the people are doing is they are connecting an accelerometer. So from the accelerometer, they will try to receive the signal. And the signal, whatever we are getting, that particular signal, it's not what you can say, it is in terms of millivolts only. So I need to, if I want to study the characteristic of that particular signal, I need to boost that particular signal. So that's why in any particular system, if you see in the signal processing system, the input signal, after input signal, we can have the pre-processing circuit. After pre-processing circuit, we can, what you can say, we can do the analog to digital conversion, then digital to analog conversion, then output will come. So why do I need the pre-processing circuit in any particular signal processing system or in any instrumentation system? The idea to have that particular pre-processing circuit is in order to boost the signal, in order to amplify the signal, in order to filter the noise. In all these things, I can use that particular thing. So, and also there are different types of features which we need to determine to know the characteristic of a particular signal. Suppose if I take the speech signal, So in the case of speech signal, the features are the basic idea to measure the features is to know whether the speech signal contains the voice or unvoiced signal. So in order to know the speech contains the voice or unvoiced, I can find out the energy, I can find out the autocorrelation. These are the things that I will try to show in afternoon, that is by using the Python, how we can determine these features. Okay, so to identify the characteristic of a speech signal. So the feature enhancement is when you get the some signal processing aspects, in order to know clearly the characteristic of a particular signal, I need to boost the particular signal or they sharpen the image. So this is the third important the feature, the characteristic, the operation is feature enhancement. The first one is signal analysis, second one is signal decomposition, third one is feature enhancement, fourth one is the noise reduction. So noise reduction means there are two types of noises which we can come across in a system. What are the broad noises which we can come across? Can anybody tell me? Broad noises. Broad noises.
Gaussian set.
Okay, that is Gaussian. Can anybody know the endogenous or exogenous noise? Endogenous or exogenous noise?
No, sir. First time we are listening. I'm
First
listening.
time. First time. So, are you faculty or a student, ma? Scholar?
Yes, sir. I am faculty.
First time you are hearing
Yes, yes,
endogenous,
sir.
exogenous. I think you know that, but you're not come across like that. Do you know about the when you perform any particular circuit, there are certain internal noises are there.
Yeah, those noise we know because of the
Thermal
material.
noise, Johnson noise.
Yes,
Yes.
thermal noise, junction noise.
Yes, yes. Those are the
Gaussian.
things, endogenous noise, exogenous noise. Within the components of a particular circuitry, whatever we are coming across the noise, those are called the endogenous noise. Exogenous noise means the external. Suppose when you keep some particular sophisticated equipment, we will try to protect it. So why we can say that we sometimes in particular the labs we cannot use our shoe and we can go inside, we can remove outside, is it right?
Yes,
Okay,
sir.
so
Actually,
ah,
sir, actually in general books, in books they used to give internal noise and external noise, but
okay,
terminology you are using that is different.
so you are not studying textbooks, huh? Internet only
Yeah,
you are
no, we have studied, but we haven't come across this terminology.
yeah. Okay, so that's why, yeah, of course, we know things, but we are not come across these things actually. Okay, so these are the type of noises which we need to remove these particular noises. Okay, noise reduction. Then another one is there is actually the noise reduction is not a simple task. It's a vast the ocean, we can say that. Okay, so just now somebody told about Gaussian noise, different types of noises. Okay, so all these particular noises, what we can come across. So in order to eliminate these noises, it's not easy. So we need to apply different types of filters, and we need to apply different types of what you can say. Sometimes flicker noise will be there, and we need to remove that particular flicker noise. Or in the aerospace, we will talk about the clutter. So in order to remove that particular clutter noise, you need to apply different techniques. So there are sophisticated methods that we need to apply in order to remove these particular noises. Then coming to the signal compression. So in the signal compression, so why do you want to go for the compression actually? Why do you want to go for compression? Can anybody tell me why do you want to go for a compression?
We can reduce the size so our bandwidth will
Yeah.
data rate will increase.
Yeah. Okay. So there are different types of compression techniques are there. Now signal encryption and transformation. So encryption is in order to maintain the security purpose, we can go for the signal encryption. So like this, we can what we can say the different types of the techniques that we can use it in the case of signal processing. So overall, the type of the important operations that we can come across are why do you want to go for signal processing is signal analysis, signal decomposition, feature enhancement, noise reduction, signal compression, and signal encryption and transformation. So these are the very important aspects in the case of the signal processing. Okay. So we will move to other part. So of course, I am not touching this thing. So this is the signal analysis, how we can do. We'll take a analog input. So there is an analog filter, as I told, analog to digital converter. Here we will apply the DSP algorithms. And here we can have a time domain display, frequency domain display. And this is the spectrum of a particular this signal. If you take the audio signal and how we can get a spectrum. Okay. So this is one example about the signal analysis. So this is the speech data. We lost the golden chain. If I speak like this, we can represent the speech data like this. And this particular speech data, you can get a spectrum. As I told you that the transitions, peaks, and frequency distribution, we can analyze the signal. So these are the peaks actually. Wherever the peaks are there, there is a the signal content that is present. Okay. So here we don't have any particular signal. And the distribution of the frequency, you can see 500 Hz, 1000 Hz, like this different frequency, the distribution will be there. So from this particular plot, I can study the characteristic of a particular this signal. So when you take a speech sample, from the speech sample, we can analyze the this spectrum by having some particular parameters. Okay. So this is about the way in which we can analyze a particular signal. Okay. So this is about the basic idea about the signal processing. Why do you want to go for the signal processing, signal analysis? So these are the basic fundamental ideas. Now coming to the first signal processing is radar signal processing. As I told you that radio detection and ranging. Okay. So one of the first signal processing application by using that we can aging, stability, sensitivity, we can find out with the help of the signal processing application. So coming to the different fields of signal processing, now I will try to show that these are the fields where we can come across in all these particular domains, we can use the machine learning techniques, artificial techniques, or with the help of the different tools, either LabVIEW or MATLAB. So we can use those tools and we can process the different types of fields. So one by one, I'll try to discuss. So 2 minutes, just I'll take water and I will take. So any doubts up to now? So whatever we discussed. So anyone, can you ask any doubts or clarification? So 5 minutes time I will give, and we can, because the other part, the different domain, I will go 5 minutes. So for you that you can ask any clarification, any doubts. Anyone? Please ask. So all the participants are from AP or any other places, from other parts of the places are attending this program?
Actually,
Apart-
sir,
Huh?
Thanks, sir.
Any other
Thanks, sir.
group?
Sir,
Tell me.
basically, I'm from Uttar Pradesh, but I am teaching in Andhra Pradesh.
Okay, nice. So
Yes,
up
yes,
to
sir.
now, we discussed any clarification or any doubts? Please respond.
No, it is clear,
Good
sir.
morning, sir. I am Kalaivani, sir, from Coimbatore.
Okay, madam.
Yes, sir. I understood, sir. The topics are very clear, sir. You can proceed, sir. Thank you, sir. I am from Coimbatore, Tamil Nadu, sir. Dr.
Nice.
S.N.S. Rajalakshmi College of Arts and Science. I am Associate Professor and Head in Computer Technology Department, sir. Throughout the session, I was listening, sir. So it's okay, sir. It's very clear and very informative, sir.
Okay, thank you, madam.
Any doubt, we'll call you, sir. Yeah, sir. Clarity. Thank you, sir.
So I think very good that most of the people they're attending. In fact, you are heading the department and are sitting means definitely that will be very nice to get the knowledge. The people from all parts of the people are coming and listening. Good, Dr. Rangaraj, Professor Rangaraj Garu, okay, for initiating the steps to organize this program from your institute.
Thank you very much, sir.
So now I think the first signal processing, then the different types of the signal processings are one is the statistical signal processing. So in the case of statistical signal processing, so we can analyze, extract the information from signals and noise based on their stochastic properties. So stochastic properties means, so I think you have come across the mean, mode, variance. So all these particular statistical parameters, suppose if I have the suppose x1, x2, x3 up to xn. If I want to know the mean of a particular the numbers, I can use this sigma x1 plus x2 plus x3 by n. Like that I can calculate. Standard deviation sigma square I can calculate. Variance I can calculate. So these are the things that I can use in the case of statistical signal processing. Statistical signal processing is actually there is a actually in the there are two types of the estimations are there. One is called the parametric estimation, other one is the non-parametric estimation. Anybody have idea about parametric and non-parametric estimation? I will tell. There are three types of approaches: autoregressive model, moving average model, autoregressive and moving average model. The way in which we can represent a system function, h of z equal to, suppose x of z is the input, y of z is the output, then I can represent the system function h of z is equal to y of z by x of z. So I can represent these things by using the autoregressive, the moving average, autoregressive, moving average approaches. I can represent the particular the signal. So those things will come across in the case of the statistical signal processing. In the statistical signal processing, I can use this particular stochastic process and I can apply the parametric or non-parametric estimation approaches and I can process. So this is first one is the statistical signal processing. Then the second one is the audio signal processing for electrical signals representing the sound such as speech or music. I can use the audio signal processing. Okay, so in order to know the speech or music, I can process this audio signal processing. Then speech signal processing for processing and interpreting the spoken words. So just now I gave one example and how we can study that particular spoken word. So we can use that particular speech signal processing. From the spectrum, we can analyze the different characteristic of a particular signal, speech signal processing. Then image processing in digital cameras, computers, and various imaging systems. I can use this particular image processing. So this in the case of the image processing, so image enhancement, image segmentation, and the image decomposition. So different types of the domains in the case of image processing. Most of the things These days, actually, in the computer science department, people are working in the case of computer vision and the vision and its applications. And in fact, the speech processing, image processing, the most of the researchers are working in computer science, like big data analysis has come into picture. So in the big data analysis, content addressable, address receivable, so all set of things, nowadays actually people are working in the domain of computer vision applications, where we can come across this image processing or a speech processing applications. Numerous applications are there. So in all these things, we can use this machine learning and artificial techniques in order to perform these particular tasks. So image processing, then video processing for interpreting the moving pictures. I can use this particular the video processing. This is also another interesting domain where we can come across the machine learning or artificial intelligence techniques. Array processing. For processing the signals from array of sensors, we can use this particular array of processing. We did actually one project with DRDO Chandipur, where in the case of DRDO Chandipur, we placed different sensors across the seashore, and then we can transmit the signals, and we can retrieve the particular the signals from opponent side. So when they are firing that particular bullets, so then from which particular direction that sound is coming, and then from that we can hear and we can take the measure steps. So that is actually the array signal processing. And even in the case of the earthquakes, people use this particular the array processing in the Japan or Korea. So most of the places, so people use different types of sensors, and if any vibration comes, so immediately they can identify the signals that the whatever the earthquake that comes before, they will take the steps or measures. Okay, array signal processing, then seismic signal processing. Okay, this is also we can use it in the case of the earthquakes and tsunami. We can use this particular seismic signal processing. Then, so those are the different types of fields where we can come across the signal processing. Then different types of applications in the case of communications, instrumentation. Then we can have the industrial control, medical application, patient monitoring, ultrasound equipment, diagnostic tools. So we can use this particular image enhancement. I can use. Then in the case of consumer electronics, military, so especially the secure communication, sonar processing, image processing, radar processing, navigation, we can use this particular the DSP applications. So, of course, this is the microprocessor DSP. I'm not touching these things. So these are the different types of basic signal processing techniques people use: convolution, correlation, bilinear transform, discrete Fourier transform, Z transform. Okay, so I'm not touching these things. Convolution, it is the actually the, as we have seen that how we can convolve the two signals xk and h of n. Okay, DFT is another the important the operation in the signal processing, which is used to determine the energy of a particular signal. Correlation, which is used to measure and describe the relationship between two variables. Two forms of correlation are there. One is autocorrelation, other one is the cross correlation. So as I told you that by using the autocorrelation, okay, and the cross correlation, we can know the similarity of the two signals. So these are the applications of cross correlation. In the case of cross spectral analysis, detection, recovery of signals, pattern matching, delay measurement, we can use the correlation. Okay, so calculation of energy spectral density, detection and estimation of periodic signals, matched filtering, target ranging. Okay, of course, these are different types. So these are the two filters, IAR and FIR filters, which we can use it. So these are the advances in DSP where we can use this particular signal processing. Rather, the machine learning techniques also we can use in all these particular advances In the case of signal modeling, I can use the machine learning. And in the case of optimal filtering, as I told you that optimum filtering, so whichever the filter which is used to determine the nearest what I can say solution to a particular problem, I can use the optimal filtering, spectral estimation, then adaptive signal processing, then we can have a multi-rate signal processing, then speech processing. Adaptive signal processing, that I will try to discuss now. Spectral estimation, as I told you, that parametric, non-parametric estimation. Then the multi-rate signal processing, where if the sampling rate is if you want to change the sampling rate depending upon the application, I can use the multi-rate signal processing. And coming to the speech processing, in the case of speech processing, the afternoon I will try to discuss about the speech processing. Okay, so these are the different advances in the case of the signal processing. Of course, these are different domains of the advances in the signal processing. Okay, so coming to different types of applications where we can use this particular signal processing in engineering. So you can see that in the case of the different the robots or different prototype models, if you want to use, we can use this particular signal processing. See here, wind energy calculation, I can use this particular thing. And then there is the complete the IoT. So these days, recently there is the car called MG Hector. Okay, so in the case of MG Hector, that car itself IoT, the 4G effect is there inside the car. So all sort of things, the top roof, if you want to open, or if you want to the play songs, or if you want to the operate any particular function in the car, I can use this particular IoT technology with the help of the chips the built in a particular car. So all those things we can do it with the help of signal processing application. Then if you see the universal counter, so the advanced detection is how many number of vehicles are going. Okay, so we can detect the number of vehicles. And in fact, earlier I worked in Bangkok, as I told you in the first day. So the official authorized vehicles we can track, and we can count the number of vehicles, how many number of vehicles which they are entering into a particular the place. So those things which we can do it with the help of signal processing application. Sorry, so I think there is an unmute occur. So all sort of what you can say, the vehicles, the how many vehicles are coming, and how many vehicles are the authorized vehicles. So those things which we can identify with the help of signal processing application. Then this is actually the another application where we can see that in dams actually the dams you can see that remotely. So if train is going, if any particular the what you can say loading effect if it comes, or if suppose any if any some particular bomb blast if it occur, so it will try to detect that particular incident, and then it will give the information. So this is actually the artificial intelligence and expert system technology. They will keep the AI sensors to detect and quantify the fatigue crack growth in the real time. So during the rainy season, so there is a fatigue, what you can say, crackdown that occur even in the hot times. So there is a cracks if it occur in the tracks. So easily there is a wireless network or satellite transmission, so they can identify these things. So this is actually this is actually the what you can say, one application of one application of the AI and expert system, which we can use it for the signal processing application. Okay, so then another one is you can see that the master control, the air traffic control system, where the tracking of a particular objects. So air traffic control system, we can use that particular, the when aeroplane when it goes, so we can know the track position of this particular thing, complete control from ATC center. So unless the ATC from ATC, if the signal does not go to a particular plane, they cannot move. So this is one particular air traffic control, and this is another air traffic control. So in between, when the flight starts from here and it reaches to this particular place, during this particular place, there are different air traffic control systems are there. So that's what earlier when YS Rajshekar Reddy, the previous ex chief minister, died. So during that time, actually, this suddenly the air traffic control signals are stopped. Then automatically the people where this particular signal stop, they identified, that means in this particular location the incident may occur. So like that, the people can identify the position of the target by using this particular air traffic control. So this is also one way of the application where we can use this particular signal processing technique or the artificial intelligence techniques in order to track the position of a target. Then there are a number of robots, as you have seen that automobile, the people are using to do some particular, what you can say, automobile manufacturing. Earlier days, manually people are doing that particular the the parts preparation. Now the robo can prepare these particular things. So this is actually the optical, the signal processing devices. Okay, so optical signal processing where we can come across, and these are some of the biomedical electrical signals. People told that ECG signal, the heart electrocardiogram, by using this particular signal we can determine. Okay, so different types of the basic unit of nervous system, nervous cell or neuron, the basic function of the neuron. Okay, so this is the bioelectrical signals we can study. All these things actually we can use it. The heart rate, that is, as I told you, that PQRST. So left ventricle, okay, left RTM. So we can study the what you can say, the characteristic of a heart. And this is the skin, actually galvanic skin response. Okay, so we can find out, and we can do pulse oximeter also to know these days actually under COVID. So SpO2 levels we can find out. This we can use it. This is the EOG signals, retina signals, which we can do it. So all sort of things that we can use it in the case of bioelectrical signals. And of course, in engineering applications, we can use. Okay. So all these things are the IoT applications. So these are the various applications where we can come across. In all these things, these days people are using the machine learning AI techniques. This is one free vibration sensor response measurement. Okay, so we can acquire the data acquisition system and we can handle the example. This is actually the image acquisition computer vision. Okay, So this is actually the what you can say, the computer vision, biomedical computer vision application, real-time face recognition, then large-scale camera networks, and handwriting recognition. So by using the handwriting, as I told you that the heart rate or the what I can say is the what I told is actually the stroke, if it comes depending upon the handwriting also we can determine. So these are the different applications where we can come across artificial intelligence techniques in order to determine. Okay, so these are the other applications. Okay, so this is about the first part, that is signal processing and applications. Different applications where we can come across the machine learning and artificial intelligence techniques. And of course, you should have the overall the idea about the signal processing. Okay, so then afterwards I'll go for the I will throw some light on adaptive filters in the second part. So this is my first part. So overall, any clarification or any discussion? So 5 minutes, I can take rest. I can take water, and you can ask anything. Just 5 minutes, you can relax. I'll take some coffee and I'll start. So you can think and just 2-3 minutes. Okay, I will come. So you can relax and then you can ask me, and afterwards I'll take 2-3 minutes. Give rest. So then I will start. So any doubts? So please, 2 minutes time. So please ask anything. Hope all are there in the class. Or Professor Rangarajan Garu?
Yes, sir. Yes, sir. All are there, sir. Yes, sir.
Okay. So please respond. So I think that I'll move to second part. So another 2 minutes.
Yes, sir.
Okay, sir.
So you have come across all these particular signal processing aspects. Of course, so people are familiar with these things. So this is the time where you can take the different types of applications and you can make your students to work in this direction. I think especially, just now, madam from Coimbatore, she called, these days actually people are working in speech and image processing with the help of machine learning techniques. So you can encourage your students, I think from Gujarat, and it's very nice because most of the students these days actually they are coming forward to do internship. So they are sending the informations. So the students, they have a talent, but only thing is we have to show different types of applications and we can make them to work in this particular direction. Shall we move to other part? So quickly, I can another 20 to 20 minutes, 25 minutes. I'll try to cover the adaptive signal processing. By 11:30, 11:40, we can complete. And afterwards, we can have the 5-10 minutes discussion and then we can close. Is it visible?
Yes, sir.
Yes, sir.
Visible, sir.
Okay. So now I will try to give an idea about the adaptive filters and applications and some of the algorithms. Briefly, I will try to discuss. Anybody have come across the adaptive filters? Do you have any idea? So we have a conventional filter and adaptive filter. Why do you want to go for adaptive filter? So basically a filter which is used to process the signal in order to extract the information about the prescribed quantity of interest. Okay. There are two filters are there, analog filter and digital filter. Okay. But we have the ordinary FIR and IR filters are suitable for what I can say the uh, so is it my screen is visible? I think some names are coming here.
Yes, sir. It is visible, sir.
Visible, sir. It is visible, sir.
No, but for me, my complete PPT is occupying with the top, all these left side and right side, these participants list is coming.
Okay, sir. Okay.
You are selecting a gallery view, sir, I think. Change that one, sir. Speaker view. Change that one into speaker view, sir.
Speaker view, where it will come?
Sir, in the view, sir.
It will come on right side, sir.
Right side.
What are the options are there, sir?
Sir, is it okay, sir, now?
Record on this computer.
Sure, sir.
Hello?
Is it okay, sir? It's okay.
For me, man. For you, it's okay. But
Sir.
for me, it is completely.
Sir, go to view, sir, view.
Uh,
There is a window on top right corner, sir, view.
is it visible, my PPT now?
No, sir.
No, sir.
Sir, again share
No,
your screen, sir.
sir, it's not.
Sir, you have option called share screen,
Yeah.
sir.
Share screen only.
I request all the participants, don't share anything on the screen. Please stop sharing. So participants are requested to stop sharing.
Sir, we don't have access, sir.
Are you not visible? Is it not visible?
Sir, it's visible.
Okay. So we have the conventional FIR and IR filters. If you use these filters, suppose if the signal and noise are different, okay, so then we can use the FIR IR filter and we can process. Okay. But suppose the problem where it comes is when the signal and noise overlap. So if signal and noise overlap, in such case, it's difficult.
Yes, sir. It's not visible, sir.
Huh? Okay. No, it is visible now.
Visible, sir.
Somebody is telling it is not visible. Is it visible or not? No?
Sir. Yes,
Hello?
sir. Visible, sir. Visible, sir.
Okay. So
It's
see,
visible,
here,
sir.
Sir, visible, sir.
the signal and noise are overlapping each other. In such case, I can use the adaptive filter. Okay. So when I can use the adaptive filter means this is the designed signal and this is the interference. You see here, the interference is dominating the desired signal. So when there is the spectral overlap between the signal and noise, or the band occupied by the noise is unknown or varies with respect to time, then I can use the filter, the adaptive filter. So conventional filters are used where the signal and noise occupy the fixed and separate frequency band. That is, in such case, the coefficients are constant. When the filter characteristics are to be variable and adapted to changing the signal characteristics, the coefficients of the filter should vary and cannot be specified in advance. So the adaptive filters are used where there is the spectral overlap between the signal and noise, or if the band occupied by the noise is unknown or varying with respect to time, I can use this particular adaptive filters. So what is the structure of adaptive filter? This is the structure of an adaptive filter. We can have the variable filter, then there is an update algorithm. So a digital filter with self-adjusting characteristics and then it adapts automatically to changes in the input signals. So this particular, the application of this particular adaptive filter is, we can use it as a noise canceller. Okay, so here, so here we can use the adaptive filter as a noise canceller. Okay, we can have a digital filter, then an adaptive algorithm. Here the signal plus noise, and then we can take, of course, the reference noise. I will try to give the example. So here the estimated signal, suppose when you take the signal which is contaminated with a noise, so signal with a noise, okay, and let us take the signal and noise are uncorrelated with each other, then in that case the estimated signal is equal to EK equal to SK cap. This SK cap equal to YK minus NK cap. That is equals to SK plus, what is YK? YK equal to SK plus NK minus NK cap. So the output, whatever we are having this particular, the estimator output, it will do two things. One is, which is an estimate of the desired signal, and which is an error signal, which is used to adjust the filter coefficients. So there are different applications of adaptive filter. One is to we can use the, so this top I want to eliminate. How we can remove this one? I think chart now I can get it. Okay. See here, the first application is, in order to identification, we can use this particular adaptive filter. So for that, we can keep the unknown system in parallel with the adaptive filter, and we can get the output. Then we can use it as a inverse system. If we connect the unknown system in series with the adaptive filter, I can use this inverse of a system. Then for prediction, I can use the adaptive filter. So like that, we can use the adaptive filter for system identification, in order to have the inverse system and the prediction and other part of applications. We can use this particular adaptive filter. So in the case of the digital filter, normally we can use the FIR transversal filter. In the case of adaptive algorithms, we can use the three algorithms. One is LMS algorithm, RLS algorithm, other one is the Kalman algorithm. So before going to see the idea about the least mean square algorithm, the basic origin for this particular LMS algorithm is Wiener filter. See here, this is actually the Wiener filter. It is an open loop system where the signal plus noise, which we can connect, and we can take the noise, and then we can get a particular output EK. So the estimated signal is E is equals to sigma I equal to 0 to n minus 1 W of I x k minus I. So when you see the basic theory from this, I am not touching this particular theory, but ultimately we can calculate the error from the error EK square. So we can get we can calculate the, what you can say, the mean square error J is equals to sigma square plus 2p transpose W plus W transpose RW, where P is the cross correlation factor, R is the autocorrelation factor. So when you want to calculate the error performance surface for Wiener filter, which consisting of the cross correlation and autocorrelation matrix. So in order to overcome these two, so we will go for least mean square algorithm. So that is the idea. So here the optimum value of this particular error performance. This is actually the, if you want to have the estimator should be minimum, we need to calculate the optimum value. So the optimum value is equals to R inverse into P, where R is the autocorrelation, P is the cross correlation. So this is called the Wiener-Haupt equation. As the number of samples are more, then this calculation of R and P is difficult. So we can go for the other algorithm where we need not calculate the autocorrelation or the cross correlation. We can do it with the help of samples. That is called the least mean square algorithm, that is LMS adaptive algorithm. So this algorithm, which is used the machine learning techniques, where we can calculate the what you can say or in order to estimate a particular signal, we can use this particular LMS adaptive algorithm. So here we can have WK plus 1 equal to WK minus mu into del K. And we can implement this particular algorithm like initially we can set the weights WK of I equal to 0, 1, 2 up to n minus 1. Then we can compute the filter output nk cap equal to sigma I equal to 0 to n minus 1 WK of I xk minus 1. Then you need to compute the filter estimate, then update the next filter weights, that is WK plus 1 of I equal to WKI plus 2 mu EK xk minus 1. Okay, so like this we can do it, compute this particular LMS algorithm by sample by using the steep descent algorithm. But there are certain practical limitations of this particular the LMS algorithm. One is effect of non-stationary. Suppose if the particular the error performance surface, so if the coefficients is varying, the error performance varies. Then effect of signal component on the interference input channel, then the computer word length requirement. Okay, so then coefficient drift. So all these things actually the limitations of this LMS algorithm, so that we can go for the other LMS based algorithms like complex LMS algorithm, fast LMS algorithm. Okay, so like that we can use different types of LMS algorithms, and we can what we can say the perform the particular least mean square algorithm. So an adaptive algorithm is self-adjusting filter where we can process a particular signal. There are the different types of the algorithms which we can use for the updation. One is the Wiener filter, another one is the least mean square algorithm. And in order to overcome the limitation of least mean square algorithm, we can go for recursive least square algorithm. Of course, this recursive least square algorithm also by using the regression and the machine learning techniques, which we can use it in order to find out. Okay, but the recursive least square algorithm will give the faster convergence rate. But when you take the least mean square algorithm, so in the case of the least mean square algorithm, the sample by sample conversion, but a recursive least square algorithm is a complex process. Okay, so there are certain limitations of thing, even though it gives the faster rate of convergence, but disadvantages are the computationally complexity, sensitivity to round of errors that accumulate as a result of recursive computations. So this is the comparison of LMS and RLS algorithm, where you can see the number of iterations. Of course, in the RLS algorithm, it will take immediate, but the LMS algorithm is a gradient algorithm. Without having the complexity, we can achieve the performance. Okay, and there is a third algorithm is Kalman filter. As I told you, it is a optimal recursive data processing algorithm. So in the optimal recursive data processing algorithm, optimal means we can take the system and measurement device dynamics, statistical description of the noise, and initial conditions of the interested variables, all these things which we can take it. Of course, this is somewhat typical one by taking the Doppler rudder, the velocity indications, pilot and static measures, all these particular the information we can take and we can process. And recursive means actually, so it does not require the previous data. Okay, only the current the value, if it is there, we can process. I'll give an example. In the case of non-recursive solution, suppose if you want to do some particular, what you can say, estimate the mean of a random sample. Let us take Z1 to Zn. And in order to calculate these things, first what we'll do is we'll store the Z1, and that is the sum, and estimate the mean as M1 equal to Z1. In this case of the second measurement, store Z2 along with the Z1 estimate mean as M2 equal to Z1 plus Z2 by 2. And third measurement is store Z3 along with Z1 and Z2 and estimate mean as M3 equal to Z1 plus Z2 plus Z3 by Z3. So like this we can calculate, but we need to remember all the values. So which will increase with the time. More arithmetic operations are needed, leads to problems with increasing data. Okay, so like this we can take like this we can take we need to calculate the values again and again. So because of that the time will be more, and then the what we can say um, the more arithmetic operations are needed, and then we can it leads to different problems with increasing in the data. Okay, but in the case of recursive solution, you just observe the recursive solution how it will do. See here, in the first computation, compute the estimate as M1 cap equal to Z1. We will store the we will store the M1 cap and discount the Z1. In the second measurement, we can compute the estimate as a weighted sum of previous estimate and current estimate Z2. So we can store the M2 cap and discard Z2 and M1. And in the case of third measurement, compute the estimate as a weighted sum of M2 cap and Z3, and we can store M3 cap and discard Z3 and M2 cap. So like this, the recursive computation by using the machine learning techniques, which we can do it, and we can store only the current values. That is the major advantage of this particular Kalman filter. Okay, so no need to store all the previous measurement. Previous computational efforts are used to good advantage, and algorithm can proceed to infinity without growing a memory problem. And data processing algorithm is so the central processor which we can use it. So this is about what we have seen, that the Kalman filter which can be used as a the optimal recursive data processing algorithm. Okay, of course these are the some of the basics about the Kalman filter, not necessary. Okay, so in the tracking and navigation we can use. Okay,
And Kalman filter is not working for, not suitable for static signals, sir.
what month?
Sir?
What month?
Hello, sir.
Tell
Am
me,
I
tell me.
audible, sir?
Ah,
Kalman filter works only for static signals, sir. Kalman filter works only for static signals, sir. When you work with the dynamic signals,
ah.
the Kalman filter was not working, sir. At the time
No,
of that, we are using another Kalman filter that is nothing but hybrid Kalman filter.
yeah. No, for that's
Will be
what.
useful, sir.
No, there are two types of signals: linear and non-linear. Okay, for non-linear we
Yes,
can
sir.
go for extended Kalman filter. Okay, so there we can use the
Yes, sir.
Taylor series method, and we can convert. We can use the extended Kalman filter. And what you are telling is the first one is actually the adaptive Kalman filter will come, bank of filters. Then we can go for hybrid Kalman filtering. That's true actually. Okay, so for that actually we can use this particular hybrid type of Kalman filter for dynamic signals, whatever you told. Okay. So basically, this is actually the origin of a particular the filter. Of course, completely it is a mathematics. Okay. So basically, we can see that I will show the operation. This is the predict and correct, the time update and measurement update. We can use it in order to measure the calculating the particular signals. Okay, these are the equations, the time update equations in the discrete Kalman filter, xk cap and pk cap minus. Okay, so measurement update equations. So these are the complete picture of the operation of the Kalman filter that we can use it. So this is the signal flow graph for the Kalman filter. Okay, so of course, technically there is a process noise, and then this particular the operations. Of course, this is called the signal flow graph where we can come across. And the adaptive filters, we can use it to further different types of applications. One is room acoustic identification. We can use this adaptive filter. So you can use any type of adaptive filter, whatever we discussed. Okay, this is the broadband white noise signal. Okay, DTA converter and A to D converter, and we can use the adaptive filter. Okay, we can remove this particular EK equal to 0. Then the transfer function of the adaptive filter must be suitable for a model of the acoustic transfer function. There is echo cancellation. We can use the adaptive filter. Okay, echo cancellation we can use. Noise cancellation we can use the adaptive filter. These are different types of applications where we can use this. So channel equalization is another important the application where we can use this particular the adaptive filter. So even in the channel equalization, people are using these days actually the machine learning techniques they are using. Okay, and CDMA interference suppression. These are also another adaptive filter application. CDMA interference suppression. And these are the research areas where adaptive signal processing can be used. One is target tracking, then satellite communication for time synchronization, wireless communications where channel equalization and estimation, and smart antenna systems you can use. Medical signal processing for heartbeat monitoring, image analysis, face recognition, optical character recognition, control of electric motors, restoration of old image, video and audio signals, and many more we can use. Okay, so these are the various applications of the adaptive filters. Okay, so now 5 to 10 minutes now overall and adaptive filters, you can ask anything we can discuss now. Okay, so we can interact the different techniques whatever we discussed. Okay, so now it is time for participants. You can share your talk and where you are working in this particular domains you can discuss. So you please discuss and
Participants, you can unmute yourself and respond to the speaker, please.
so 5-10 minutes. So now you can share your the experience or the interaction. Any doubts are regarding the topics. So since morning we discussed about various applications of signal processing and then adaptive filters, different applications. Okay. So if you have any clarification or if you are working in these particular directions, it's most welcome. Okay, so you can share your knowledge also so that we will also know that. Okay, so you can discuss, because of course these are the topics actually the people are using, as I told you, that of course, the machine learning, artificial techniques, they're not new techniques actually. In fact, the olden days people are using those things actually, but now the order of the day has come to the machine learning and artificial intelligence concepts. So in all these things, actually, we can come across the feature extraction as well as the feature classification. And as I told you in yesterday, we can come across the machine learning concepts like the artificial intelligence means how we can make the computers to do better things than human being. So we need to embed the programming concept such that it can understand the concept of this particular the technique and it has to work. And the second thing is in the machine learning concept, mostly the supervised learning, unsupervised learning people use. And still, if you want to have the high resolution and if you want to have the accuracy, the hidden layers, if you want to use it and if you want to perform, so then we can go for those techniques, different types of, I think, neural network approaches people use in order to process such type of things, especially the pattern recognition and some particular two-dimensional image analysis. People are using these the techniques. Okay.
Hello. Hello, sir. Am I audible?
Yeah.
So actually, I'm working in a EMG signal.
Yeah.
Muscle signal, and topic is a different body movement analysis.
Okay.
So actually, just I have started the work.
Yeah.
And finally, I have to implement on a hardware like FPGA.
Okay.
So, sir, is it a possible real-time analysis in a machine learning on hardware?
No, actually, the thing is, first you must understood that there are two things. Okay, one is the simulation part, other one is the hardware implementation is different. Okay, so when you want to the do hardware part, either you can use it the FPGA implementation, either you can use it IoT enabled, and in real time, if you want to use it, continuous tracking, you can use the machine learning. Okay. The first thing is, as you told that EMG signals, in order to know the body movements and all those things. So you need to extract the body movement signals. And you need to select the features from that particular the signals. You must be in a position to identify which are the different the body motion signals which you are concentrating. So for that you need to go for the feature extraction and feature selection, and afterwards the classification will come into picture. Of course, when you develop the prototype model, you need to have all these things continuously in the real time. It should work. But when you want to implement an hardware, FPGA, so normally what we need to do is whatever the program that you develop, you can dump into FPGA and we can test it. Okay.
Yes, sir.
So, but mostly
Nowadays, body is a
no, mostly what I feel actually, of course, the FPGA, DSP processor, all those things, in order to have the computational aspects and computational complexity in that direction, you can go. But my idea is, why didn't you go for a Python and you can do some particular the Arduino board or Raspberry Pi, and you can implement and you can develop a prototype model. I've understood my the idea. Hello, I think you have any connective problem.
hello. Am I audible now? See?
Yeah. Are you hearing my voice?
Yeah, yes, sir. Actually, in FPGA, we get a good means performance. and
Yeah,
less time.
performance is computational complexity is good in FPGA, sure. Okay.
Yes.
But what I mean to say is the usable portable device, you try with Python also. Okay.
Yes, sir. And also nowadays, sir, FPGA also support Python language.
If that is compatible is there, definitely you can use that. Okay.
Yes, sir. Yes, sir. Thank you, sir.
Yeah, good. Okay, if you don't have any questions, so afternoon, what I'll do is I will try to give a talk on speech processing. Then afterwards, quickly, I can show some demos hands-on, and I can make my scholar to give some particular hands-ons about these particular the aspects, and how we can perform generate the signal, or the how do you calculate the features, how do you check this particular LMS algorithm, all those things, just I will make you to understand, because Dr. Suresh, I think he gave the Python fundamentals, and now signal processing aspects, how we can perform with the help of this particular Python, we can discuss. Okay. Over to Professor is it Rangaraj or Rangarao Garu?
Sir, Rangarao, sir.
Rangarao Garu.
Sir.
So now, shall I
Sir,
stop?
can you listen me?
Yeah.
Sir, hello.
Tell me.
Sir.
Okay.
Okay,
Speak.
sir. Sir, thank you, sir. Thank you very much for your session, sir. Hello?
So, shall we meet at 2:15?
Yes, sir. 2:15, sir. Okay, sir.
No, because I need some more rest actually. 2:15 we will join.
Okay,
Okay,
sir.
na?
Okay, sure, sir.
Okay, ma.
Thank you very much, sir.
Welcome.
Thank you very much, sir. Thank you all the participants for joining us for this morning session of the fourth day of TP. So thank you one and all. And for afternoon session, please join us at 2:15 sharply. And we are going to post the feedback shortly, or within a few seconds. So all are requested to post, fill the feedback form. Thank you very much. Thank you.